Let's solve the equation e to the 2x plus 6 times e to the x plus 8 equals 0. So I know this looks funky as it is, but just first of all note that e to the 2x is the same as e to the x2 because 2x is really 2 times x. So 2 times x versus x times 2. And at least when it's written as e to the x times 2, it's a little easier to spot this as e to the x quantity to the second power because again, in the format of base to an exponent, quantity to an exponent, you can multiply the exponent, so x times 2. The whole point is this e to the 2x that's here, the first term, you can rewrite as e to the x quantity squared. Copy the rest of the terms as is, plus 6 e to the x plus 8 equals 0. The reason to write it like this, you see e to the x in a couple places. Let's substitute. Everywhere there's an e to the x, we're going to write a u instead. So we'll have u squared plus 6u plus 8 equals 0. Now that looks like a much more familiar quadratic equation. The left side factors. We'll have u plus 2 times u plus 4 is equal to 0. Now apply the zero product property. So u plus 2 equals 0 or u plus 4 equals 0. Subtract 2 on both sides of one equation. Subtract 4 on both sides of the other equation. We have u equals negative 2 or u equals negative 4. Now that we've solved for u, we can substitute in e to the x for each of the u's, and we'll have e to the x equals negative 2 or e to the x equals negative 4. Now the technique we're going to apply is rather advanced. It's the first time we're doing it. But the thing is, the first equation, e to the x equals negative 2, has no solution because the function, we're bringing in a function into the story here, the function f of x equals e to the x, we had earlier said that the range of this exponential function is 0 to infinity. So the range, recall what it means. Range is talking about all of the outputs, the set of outputs. The only kind of thing you can get as a value, as an output of e to the x, is between 0 and infinity. So we're never going to get negative 2 as an output. Same deal, e to the x equals negative 4 has no solution because the range of this function is 0 to infinity. So no matter what you plug in as an input for x, the output of e to the x is always between 0 and infinity. Yeah. So the output of e to the x always comes from 0 to infinity. So the result of this e to the x, it could never be negative 2. E to the x could never be negative 2. E to the x, it's a reporting of the outputs of what e to the x would simplify to be is always a number between 0 and infinity. So you're never going to get negative 2. So this neither of the two equations here actually has solutions. So there's no solution. Now this is an advanced and a rather important way of arguing that an equation has no solution. We're going to be seeing a lot more of this. So to break things down, e to the x equals negative 2 has no solution because the function f of x equals e to the x had 0 to infinity as its range. So the only possible values, the only possible y values of e to the x are in the interval 0 to infinity. So no matter what you plug in for x, whether you plug in x as negative or positive or 0, again, the domain is all reals. But whatever you plug in for x, no matter what you plug in for x, there's no value of x that you can plug in which is going to make the y value, which is going to make e to the x, have value negative 2 because the y values are between 0 and infinity. Another way to say this, the graphs of f of x equals e to the x shown here, and g of x equals negative 2, that's the right side, graphed as this just horizontal line. That's what graphing just the y value is always negative 2 looks like. These two graphs just don't intersect each other. By contrast, if you graph these two other functions, j of x equals x squared and k of x equals 2x minus 1, these graphs do intersect each other. You should try drawing those carefully, or have a computer draw those. And then these two formulas for the functions, if they're the left and the right side of an equation, so x squared for the left side and then 2x minus 1 for the right side, the equation x squared x squared equals 2x minus 1, that equation does have solutions because these two graphs intersect. But these two graphs over here, e to the x and negative 2, here they are graphed. These don't intersect. So there's no solution to the equation e to the x equals negative 2. Okay, let's find the zeros of f of x equals negative x squared times e to the x plus 2x times e to the x. Finding the zeros, just, okay, we could say, replace the f of x with a y. Just a reminder that a 0 is an x value that makes y equal to 0. So we'll set y equal to 0 here. And now there's already a 0 on one side. This really suggests we should factor the other side. And notice on the other side, there's two terms, and both terms have an e to the x as well as an x as a factor. So if we factor out x times e to the x, Then in parentheses, we're left with negative x plus 2. So now we can apply the zero product property. Because there's a 0 on one side, there's a product on the other. We can set the set the x factor, set the e to the x factor, and set the negative x plus 2 factor. Each of those can be set equal to 0. So x equals 0, fine. For this equation, negative x plus 2 equals 0. If we add x to both sides, we'll have 2 is equal to x. What about this e to the x equals 0, that middle equation? The equation e to the x equals 0 has no solution because 0 to infinity, excluding 0, is the range of f of x equals e to the x. So e to the x, its outputs are always in this interval 0 to infinity excluding 0. So 0 itself is never going to be an output. It's never the value of e to the x. So no matter what you pick for x, you just can't get e to the x to equal 0. So that middle equation there has no solution. Okay, let's do another. How about solving quantity e to the x plus 2 times quantity ex minus 2 equals 0. Notice carefully I said here ex, whereas earlier I said e to the x. That's important. So don't call this thing ex. This is e to the x. So this is ex over here, meaning this is e times x. All right, so zero product property applies immediately. We don't have to do any work to apply the zero product property. So e to the x plus 2 equals 0, or e times x minus 2 equals 0. For the first equation, subtract 2 on both sides. For the second equation, add 2 to both sides. So if e to the x equals negative 2, or e times x equals 2. Now that first equation, kind of same issue as earlier, but if you look at the second equation, this is e times x equals 2. Now e is just a number. People tend to freak out. But think about how you'd solve 5x equals 2. Right? You divide both sides by 5. So in the same way here, to solve ex equals 2, you should just divide both sides by e. E is just a number, so this is allowed. So ex equals 2 becomes x equals 2 over e. What about the equation e to the x equals negative 2? That equation has no solution because 0 to infinity is the range of the function f of x equals e to the x.